Today, we're going to explore one of the most fascinating neurotransmitters in our brain, dopamine. Dopamine plays a crucial role in various brain functions, especially in learning, motivation, and reward processing. It's often referred to as the reward molecule, but its effects are far more complex and nuanced. Let's dive into how dopamine shapes our behaviors and decisions. Dopamine is primarily involved in signaling reward prediction errors, or RPEs. These are discrepancies between what we expect to happen and what actually happens. For example, imagine you're playing a game and you unexpectedly win. The surprise of winning triggers a release of dopamine, which strengthens the behavior that led to that win. This process is fundamental to reinforcement learning, helping us learn from our experiences and adapt to new situations. In motivation, dopamine influences our decisions by modulating the expected value of future outcomes. It helps us perceive the worth of goals, making it integral to motivating goal-directed behavior. Dopamine also encodes the salience of stimuli, how important or relevant something is, shaping our motivation to engage in various behaviors.
Dopamine's functions have been understood as either facilitating learning through RPEs or driving motivation. The current model has often separated these functions with tonic dopamine changes that are slow and steady release, linked to motivation, and phasic dopamine fluctuations that are rapid and short-term bursts associated with learning. However, though, recent studies challenge this simple dichotomy. They show that dopamine can influence both motivation and movement at very short timescales, suggesting that the current model doesn't fully capture its complexity and has left many researchers with the following questions. How does dopamine toggle between facilitating learning and facilitating motivation, especially when both processes may occur in quick succession? And how can target cells distinguish whether an increase in dopamine signals is a need for learning versus a need for action?
In order to address this gap, researchers have proposed a new theory that suggests dopamine release related to motivation is dynamically regulated by receptors on dopamine terminals. This means that target neurons can rapidly switch between learning and action modes, potentially with the help of cholinergic interneurons acting as a switch mechanism. This dynamic regulation allows the brain to optimize behavioral responses based on context.
Let's look at how dopamine affects real-life conditions, and specifically ADHD. ADHD is often characterized by symptoms like inattention, impulsivity, and hyperactivity. Research has shown that these symptoms can be linked to dysfunctions in the brain's dopamine system, particularly in areas involved in attention regulation, reward processing, and motivation.
In individuals with ADHD, dopamine signaling is often impaired, affecting their ability to focus and regulate impulsive behavior. Dopamine helps prioritize important stimuli and motivate goal-directed behavior, but in ADHD, this process is disrupted. This is why people with ADHD might struggle to engage in activities that require sustained effort, even if the outcome is important. Dopamine's involvement in learning and reward prediction errors, RPE, also plays a role in ADHD. With people without ADHD, dopamine helps encode discrepancies between expected and actual outcomes, which is important for updating behaviors based on new information. But in individuals with ADHD, the dopamine system may not effectively update these predictions or modulate behavior accordingly, which can lead to difficulties with adaptive learning and problem solving. Thus, individuals with ADHD may have trouble modifying their behavior based on past experiences or adjusting to changing environments. Treatment for ADHD often involves medications like stimulants, which increase dopamine availability in the brain. By improving dopamine activity, these medications help correct the dysregulation in motivation and reward processing, enhancing attention, focus, and impulse control.
In summary, dopamine plays a central role in both learning and motivation, helping us navigate complex decision-making and reinforcement processes. Its influence is nuanced, involving multiple brain areas and mechanisms that contribute to our overall ability to learn, adapt, and stay motivated.
Understanding dopamine's role can also help us appreciate how it impacts conditions like ADHD. By recognizing how dopamine affects our behaviors, we can better manage its dysregulation and improve our overall well-being. Thanks for watching.